So in this video, I'm just going to quickly demonstrate a couple of algorithms for solving mazes. Now the idea would be for students to come up with their own algorithms, but I want to demonstrate these so they're a nice jumping off point, I guess, for students to build on. So the two algorithms I'm going to look at really quickly are the random mouse algorithm and the wall follower. Now the random mouse algorithm is essentially what it sounds like. It's like you put a mouse in the maze, he goes around the maze at random. Now to decide which direction I'm going to go when I get to a junction, I'm going to use a random number generator, in this case a coin flipper from random.org, but you could use a dice or just any other way of generating a random number. So I've decided here that heads will be left and tails will be right when I get to a juncture. So I'm going to start up here at the start of my maze and I'm going to walk in. Now at this point I could go left or I could go right. Now I'm going to flip my coin, flip, and I can see that in flipping that I got heads, so that means go to the left, so my left. So I follow that around. Now I can see that I get to a dead end here, which means I'm going to have to come back to that juncture again. Now at this point I could do a random number flip again, but I could end up going back the way I came and just ending up in a loop. So I'm actually going to go the other way until I get to another junction, which is here, and flipping again. So random if I'm going to go left or right, and that has loaded as heads again, so it's left. So my left, which is this way. Again, I've hit a dead end. I'm going to come back. Just to avoid going in a loop, I'm now going to take the other path to here. Now I've got this choice again, left or right. So I'm going to flip again. Heads again, so left. So I'm going to go here. Now you can see at this point I could go to the left or to the right. So I could either go that way or this way. So I'm going to flip the coin at this point. And that's loaded heads, which is again left. So picking this point, I've got to this part of the maze, left or right, tails, which is the right. So it's that way. But that is a dead end, so I've come back again. Just to avoid getting into a loop, I'm going to go the other direction. Another junction, left or right, flip it. It's tails, so it's right, so I'm pointing down, so my right would be this way. And last one, left or right, and it's loaded as right. So I'm going to go to the right, my right if I was in the maze, but I can see that that's a dead end, so I'd come back and then go the other way, and I get out. So the random mouse, depending on how you use it, here I avoided going in loops, but it does get me to the end, but it could take time, and especially if I was actually using that random number at every junction again, I could end up going in circles or even going all the way back out again. So it can be very slow, it can take a really long time. So I guess the version I used is a slightly modified random mouse. So the next one I'm going to use is a wall follower. Now the wall follower is pretty much what it says. The idea with this one is that you imagine yourself in the maze, put your hand on the wall of the maze, and then you follow that wall. So I'm going to do the left hand wall follower first. So imagine that if you walked into this maze, if you put your hand, your left hand out, you would be touching this wall right here. So this would be the wall that you would not stop following with your hand. So I'm actually going to demonstrate this just by using or drawing the green line right next to that wall. Imagine that you've got your left hand out touching it, and we're going to see where we end up. So put my left hand out, I'm going to follow this wall. Now you can see that in following it, I've always got that hand out, my left hand, so I don't leave this wall. So I pretty much just draw my line right next to this wall the whole way around. And because this maze is what we call a simply connected maze, so it means that all the lines are, all the walls are connected, this method will work. If you've got little areas like, off that are not connected, say there was another part of the maze over here, this method won't work because the walls are not all connected up. So this method, you can see that by following the left wall as I came into the maze, I ended up getting to the finish pretty quickly, and I didn't have to make any decisions really anywhere along the way. And the same thing will happen if I use the right hand wall follower. So again, same thing, I'll come into the maze, put out my right hand this time, which would be this wall here, and then I'm going to follow that around with my right hand out. So I'm going to just start here and just follow this wall. So imagine that you're really walking this maze in real life. So you're not taking your hand off this wall. So you're really just walking next to it the whole way around. So you can see this is a longer path maybe than the left hand, but even though it's a bit longer, I still get out of the maze in a really straightforward way. So both of those, the green and the orange, the wall follower algorithms, are very easy to implement. They may take a very long time, but you'll always get there, provided the maze is a simply connected maze. And the random mouse, again, is probably a little bit like a naive algorithm, but will get you there eventually, just by chance could get you there very quickly or could take a very long time. So that's two possible algorithms that you might look at with your students, and then encourage them to come up with their own algorithms to try and solve a maze in the quickest time or most efficient way that they can.